Athletic shoes are one of the most important pieces of equipment that an athlete purchases. Purchasing an athletic shoe with the correct structural parameter helps to control torsional and vertical forces that will enhance performance and reduce injuries. Temperature is one of the biggest factors that reduces the structural parameter of a shoe. The midsole of a shoe is made out of unstable material that is very sensitive to temperature. As the temperature increases, like running long distances, running in warmer weather, or even your body temperature of 98.6 will increase the midsole temperature. And that reduces its effectiveness of controlling torsional and vertical forces, which again will lead to injuries or it will not provide good athletic performance. So what we would like to show you today is testing a shoe at two different temperatures. The baseline would be 75 degrees, and then at an elevated temperature to show you how a shoe loses its structural parameters. What we're going to test today is the Mizuno Paradox 4, and it's in the low high stability rating. So we're testing it at two different temperatures, 75 degrees and 90. We've already put our data in for our 75 degrees from our previous testing. Shoe 2 will be the testing at 90 degrees. So let's go ahead. The first thing we're going to test is the midfoot stability. We're going to torque the shoe on the long axis 15 degrees and measure the resistance in inch-pounds. So let's go ahead with that. And that is 50 inch-pounds of midfoot stability. So once you come in here a little closer so you can see how we're placing that. So we got 50 inch-pounds. Now the next thing we're going to do is we're going to measure the rear foot stability of the shoe. And we do that by compressing the midsole under the heel, and the firmer it is, the more stable. The softer the midsole is under the heel, the less stability. So let's go ahead with this. This is measured in millimeters. So we'll compress a shoe to 100 pounds and determine how many millimeters it took to get to that. Okay, here we start. And we have 6.58 millimeters it took to get to 100 pounds. So we'll place that into our hindfoot stability. Okay. Now, the next thing we're going to measure is the rebound index of the shoe, or the energy return when we compress the shoe at 100 pounds. So let's go ahead with that. And we have 14.02 millimeters. So that's the energy return. Okay, so now we have our data here, and we can compare the shoe at 75 degrees and 90 degrees. Overall, the shoe stability has dropped from 71.2 down to 56.1. So if we dissect this a little bit more, you'll understand where the stability is lost. So in the midfoot stability, going to 90 degrees, you lost 21.88% of the midfoot stability. In the hindfoot stability, you lost 15.03%. In the loaded heel to toe drop or the vertical heel drop, you lost 13.69%. The rebound index increased 42.77%, and that's probably because we see that in less stable shoes, they tend to have a higher rebound index. In the overall stability, it lost 21.16% of its shoe support. So if we take a look at that on our index, let's come over here. So originally, the Mizuno wave paradox was in the lower spectrum of high stability. It had 71.2. If you saw when we retested it, it dropped down to 56.1. So now it's in the minimal stability rating. So you can see where the shoe really was less effective as the rise in temperature occurred. So what this suggests that when you select a shoe, you should probably select a shoe a little higher than your normal stability when you're running in really warm weather or if you're running long distances. This is where the shoe temperature will increase and the shoe will become less effective. So temperature should be a concern when you buy a shoe.